In this video, we're going to talk about natural experiments and how to use all of that data that we have collected through our surveillance systems. So, our policy surveillance systems allow us to detect changes in policies across time. Our outcome surveillance systems allow us to detect changes in our outcomes or our risk factors over time. So now we need to ask ourselves, how can we be sure that a change in policy is actually associated with a change in our outcome of interest? So whether we're interested in alcohol use, marijuana use, illicit substance use, tobacco use, or the risk factors for any of those, or the treatment outcomes of any of those, how can we be sure that our policy is actually impacting that? Well, we do that with a natural experiment, also known as a quasi-experimental design or a quasi-experiment. These are required because we can't actually randomize people to experience the effects of a different policy. We can't randomize people to live in one state or another, one municipality or another, one country or another. And we can't randomly assign different policies to different areas. We can't say, okay, United States, you are now having this type of policy. England, Germany, China, Brazil, you're having these different policies at random, and then we're going to compare you to. It doesn't work like that, and it would be kind of a weird system if it did. So we need these these natural experiments to take advantage of just natural differences in policies and in outcomes across geographic regions. So here's how it works. Here's the basic design of all natural experiments, of all quasi-experimental studies. And from this basic design, you can make it as complex as you want. But the general idea is that you have two communities, A and B, which are either next to each other or relatively close to each other. They're just not completely different. In community A, they have a new policy. We're going to call it policy X. The X stands for literally anything that you are interested in. Community B has not implemented this new policy. They're the status quo. They've done the same thing as they always have. They're the control condition. And you want these communities as close as physically together as possible so that their underlying populations are roughly the same. When we have community A and community B, once we have identified what policy is going to change or has changed in the past, we identify our outcome of interest. Whatever that is. It could be substance use, like consumption. It could be risk factors for consumption. It could be outcomes and consequences of consumption. It doesn't really matter. It just has to be something that's measurable. And we want to measure that outcome before the policy change went into effect and after the policy change went into effect. Because we want to see that change over time. And really what we want to do is see that there was some change for community A where the policy was implemented. Typically, we want to see our outcomes decrease. We want to see consumption levels go down. We want to see the negative consequences of consumption go down. And we want to see no change for community B over time. Because again, they didn't have the new policy initiative. So we wouldn't expect them to change. So our hypothesis would be that they simply stayed constant or relatively constant. So we measure them before and after the policy change, and we hope to see that community A has changed over time where community B has not. Now, typically we want this outcome in community A to go down, but it can go up or down. It just depends on what your outcome of interest is. And then community B, which hasn't had that policy change, they act as the control group. And as the control group, you hope and you pray that there is absolutely no change in your outcome of interest, because then you have to explain it away. Now, there are a lot of limitations to using this type of design. You may or may not have heard of these before, but let's just go over them again. So you have different communities. They're in different geographic regions. Even if they're towns that are right next to each other, they are in different areas, and they can experience different non-policy events which may impact their consumption. This is known as history bias. If there's some other event in one community as compared to another that impacts consumption levels, that's a history bias. It's just different histories that people are living through. Different communities may also mature over time differently. This is known as maturation bias. This can also be a type of selection bias where maybe inadvertently, maybe on purpose, you have selected communities because they would change differently over time. You knew that some areas were older than others so that maybe their substance use wasn't as high and would be more constant compared to, say, an urban center that has a generally younger population. If the people in different communities are simply substantially different, they have different cultural values, they have different baseline levels of consumption, then you run into kind of a standard selection bias. You have selected cities specifically because you expect them to be different. You don't want to do that. You want to identify different geographic regions because you expect them to be the same. And then if these communities just have extreme values, either extremely low values in what you're measuring or extremely high values, any differences over time may simply be regression to the mean. They may naturally move towards an average because they're at such an extreme range. So, for example, for a basic example, you do a survey in one community and you find not a single person smokes cigarettes and not a single person drinks alcohol. That is a very extreme value, which simply is unheard of. So when you measure them again a week later, a month later, a year later, then you're going to have regression to the mean because someone is going to smoke a cigarette in that year. Someone's going to have at least one alcoholic beverage in that year. So history bias, maturation bias, selection bias, and regression to the mean are all things to keep in mind when both executing a natural experiment and then interpreting the results of a natural experiment. The best example that I can come up with, and really the best example in addiction science for natural experiments, is the International Tobacco Control Project. This was designed to determine if implementation of the Framework Convention on Tobacco Control actually impacts the prevalence of smoking. And the FCTC is the first and, as far as I am aware of, the only public health treaty, international treaty currently in existence. It started in 2002 with only 4 countries. It's now expanded into 29 different countries from every continent but Antarctica in the world. And they have produced hundreds and hundreds of papers and results comparing populations across countries. So they have found a way to take countries which are very far apart. The US and Australia are literally a day apart if you fly from them, but have done so in a way that they're actually comparable populations. And one of the first results that came out was published by Hammond et al. In 2006, demonstrating that graphic cigarette warning labels are more effective at getting people to quit smoking and preventing people from smoking than the text warnings we use here in the United States. So if you're interested in a very effective, very large natural experiment taking advantage of natural policy changes in different geographic regions, I urge you to read into the International Tobacco Control Project more and look into the International Alcohol Control Project, which tried to duplicate this effort, but specifically for alcohol use.